So now, today we are going to discuss this very important topic, that is hardened concrete. Now we are checking all the requirement of fresh concrete. Then after it will start attaining certain strength and it will become hard. So this hardened concrete is very important when as far as the strength aspect is concerned, because ultimately this hardened concrete is going to take the load of the structure. So this various properties, that strength aspect, how to check the strength of this hardened concrete is very important aspect for this concrete. So in this hardened concrete, these are the topics that we are going to discuss. So very first thing is strength of hardened concrete. Okay. So basically, when we are talking about concrete, this compressive strength is very important. Okay. So first thing that you will learn about it is compressive strength. But apart from that, this tensile strength, flexural strength, as well as bond strength. So bond strength is nothing but it is the bond between the cement paste and aggregate and cement paste and reinforcement, that is for the RCC. Okay, so basically for compressive strength we are using this cube as well as cylinder. Okay, so you will learn in detail how to do testing for the hardened concrete. Okay, so this just you should know that for the compressive strength we are casting cubes as well as cylinder in laboratory, and then we will check the strength after 28 days. For tensile strength, generally we are using this cylinder. Okay, the same cylinder that we are using for compressive strength, the same can be utilized for tensile strength. So basically it's not the direct tensile strength but indirect tensile strength. We are doing it by splitting it, which that's why it is called as the split cylinder test also. This flexural strength, for flexural strength generally we are casting this beam. Okay, so that you will come to know when we will discuss about the testing aspect. So this standard test method that we should know about this strength of concrete. So basically three strength that are very important for concrete: compressive strength, tensile strength and flexural strength, and that we are checking in laboratory. And bond is, that is the bond between paste and that aggregate, as well as paste and reinforcement. Then also you should know the failure mechanism under compression and tension. Whenever we are applying load to check the strength of concrete, how will it fail under compression as well as under tension, that we should know. Then stress strain behavior of concrete, that we will discuss. Then overview of modulus of elasticity, that is included. And dimensional stability, basically this phenomena, that is creep and shrinkage. So after attaining strength, then certain amount of creep. So that is, there is a continuous increase in strain under the sustained load. आप लोड नहीं बढ़ा रहे फिर भी उसका strain बढ़ रहा है. So that phenomena is generally called as creep. And shrink भी हो जाता है कभी कभी concrete. So what are the factors that are responsible for this dimensional stability related creep and shrinkage, that also we are going to discuss. So these are the topics that we are going to discuss in hardened concrete. So very important thing is strength aspect. Okay, so before going to testing of all this compressive, tensile, flexural, etc., we should know about this strength aspect. That is, what are the factors that is affecting strength. So here, just in the figure, these are the testing method which are shown. This is compressive strength test. So here it is shown with the help of cube under compression testing machine. You have to check it. For flexural strength, we are using beam. For indirect tensile strength, we are using these cylinders, and water absorption test is also there. But in our laboratory, these three strength tests that we have to perform. Okay. Now, as I told you that the strength aspect, that is very important, and we should know which are the factors responsible for that. So before that, we will have one overview related to this strength of concrete. So this compressive strength of concrete is one of the most important and useful property of concrete. Okay, so generally it is said that this concrete, it is strong in taking compressive load. Okay, और टेंशन के लिए हम जनरली reinforcement bars provide करते हैं. ठीक है, so this compressive strength, that is the most important property of concrete. And in most of the structural application, concrete is basically used for resisting the compressive stresses. तो concrete के लिए सबसे important जो उसका strength है वो है compressive strength. And in those cases where strength in tension or shear is of primary importance. This compressive strength is frequently used as the measure of these properties. ठीक है, तो जहाँ पे टेंशन और शेयर भी चाहिए तो दिस इनडायरेक्टली वी आर कोरिलेटिंग इट विद द कंप्रेसिव स्ट्रेंथ. सो बेसिकली द स्ट्रेंथ ऑफ द कंक्रीट, इट इज द रेजिस्टेंस टू रप्चर, कि वो जल्दी से फेल ना हो जाए, उसको रेजिस्ट करना है रप्चर को. So it may be measured in number of ways, that is strength in compression, strength in tension, strength in shear, or in flexure. So flexure means bending, bend करते हैं हम उसको. Okay. So all these indicate the strength with reference to particular method of testing. So कौन सी testing method use कर रहे हैं, that is important. So when concrete fails under compressive load, the failure is essentially a mixture of crush होता है, as well as shear failure. So basically it's not pure compression that we are applying, but it may be the mixture of crushing as well as shear. And the mechanics of this failure is a very complex phenomena. It's not simple कि जैसे आपने compress कर दिया वो fail हो गया, rupture हो गया. So it's not a very simple phenomena, it's a complex phenomena. The compressive strength of concrete is generally determined by testing cubes or cylinder made in laboratory or field. Okay, so either you can cast it, and then after 28 days normally we are checking the strength of concrete. Otherwise, second thing that you can do, you can cores which are drilled from the hardened concrete. So already the concrete which has become hardened, it has acquired the strength. And after that, some time after it has become hardened, we can directly take out it as a, you can drill it. Okay, so here you can say there's some slab is there. Okay, already it has become hardened, and we have just drilled it, and we have taken a specific size of a core. So this is called as core. So that core that has acquired its compressive strength, it has attained its strength, that can be also taken out by some drilling at the site, and on this you can do testing. And generally you can do it with the non-destructive testing of the specimen of actual structure. So actual structure में से core निकाल के आप उसका testing कर सकते हैं. So that is called as core of hardened concrete. Okay, so that can be taken up from the actual structure. Actual structure से core निकाल के that you can also test. And generally you can go for the non-destructive testing method also. Okay, so in which आपको destruct नहीं करना है. Okay. So now these are the factors that will affect the strength of concrete. For workable, properly placed mixture of cement, aggregate, and water under the same mixing, curing, and testing conditions, strength is influenced by following major factors. Okay, so you should know which are the major factors which are affecting strength of concrete in general. Okay, so very important thing, and that is called as ratio of cement to mixing water. So generally in general term we are calling it as water cement ratio. वाटर का प्रपोर्शन सीमेंट के प्रपोर्शन में कितना डाला गया है, दैट इज वेरी इंपॉर्टेंट, बिकॉज दिस विल अफेक्ट स्ट्रेंथ very much. And gel to space ratio, when we are talking about gel to space ratio, we are talking about hydrated product that are developed due to hydration process. So we are not only taking its cement, but it is actually the product which is actually responsible for its strength. Okay, so gel to space ratio, so the whole space which is available, and the gel which is the actual hydrated product which has developed. Okay, so CSH gel, that is a normal gel which is obtained by the reaction of C2S C3S with water. So hydration से जो gel बनता है, generally we are calling it as CSH gel. Okay, so that is the normal gel. So actually it is responsible for the strength. So instead of talking about only water cement ratio, the more specifically you can say it's a gel to space ratio. कितना hydrated product बना है आपके total cement में. So that is important. Next is ratio of cement to aggregate. Aggregate के proportion में आपका cement कितना है. Then grading, then surface texture, shape, strength, and stiffness of the aggregate particles. So basically these aggregate particles, they are also affecting strength. But the major thing is water cement ratio. Cement का जो proportion है, that is very important. And maximum size of aggregate. So these are all properties that is related to aggregate. But the major thing you can say, it is water cement ratio, or more specifically it is gel to space ratio. So first we will discuss about this water cement ratio. So the strength of concrete primarily depend upon the strength of cement paste. जितना cement paste का strength ज़्यादा होगा, उतना ही उसका concrete, because basically you can say that this attaining strength, that is for the concrete, it is basically the attainment of strength by the cement paste. So you can directly say that it depends directly on the cement paste formation. So the strength of cement paste increases with the cement content. जितना ज़्यादा cement content डालोगे उसका strength ज़्यादा increase होगा, and decreases if it is having more air and more water. If proper compaction नहीं किया, air voids might be there, so that will decrease the strength. Water excessively डाल दिया, that would make your concrete workable, but at the same time it will reduce its strength. But if your cement content is more, then it will increase the strength of your cement paste. So you can directly say that its cement content, if it is increasing, that will increase your strength, and it will decreases if your air and water content increase. Okay, so air and water content should be less and cement content should be more in general. Okay, so to state this, in 1918, Abram, he has presented this classic law for the strength. He has given this equation for the strength of concrete. S is equal to A upon B raised to X. So here just try to understand strength mechanism of concrete. Depends upon A upon B raised to X. So what is this X? It is the water cement ratio by volume. So kitna water cement ratio has? So here you can say this X, it is B raised to X. Now this B, A and B are this constants, and that are for 28 days result, that are given by 14,000 pounds per square inch and 7 respectively by Abrams. So here this is constant. So by looking to this equation, if these A and B are constant, so you can say that solely this strength is depending upon the water cement ratio, and it is in denominator this x, and in power of b तो constant है, तो जितना power आपका x का ज्यादा होगा आपका denominator ज्यादा बढ़ेगा, and it will decrease your strength because a is also constant, a is constant, b is constant, x is the power of b, b का power है x, तो x अगर जितना बढ़ेगा उतना आपका strength कम होगा. So looking to this equation, you can say that strength of concrete is only dependent upon the water cement ratio, provided that mix is workable. Okay, mix workable भी होना चाहिए कि बहुत सारा सीमेंट डाल दिया, पानी एकदम कम कर दिया, so it will affect its workability. So fresh concrete का property will be disturbed. Okay, so this water cement ratio law, which was given by Abraham, it stood the test of time, and it is considered to be valid even today also as a fundamental truth in concrete making practice. Okay, so before Abraham, this Parrott, he has also formulated earlier in 1897 a general rule defining the strength of concrete. He has also given one equation. So that equation, it was in the form of paste and concrete in terms of volume fraction of constituents. Okay, जो भी आपके constituents है basically उसका उसने दिया. Okay, so here this strength of concrete is given by K. Again, this K is a constant. C upon C plus E plus A, the whole raised to square, means C upon C plus E plus A whole raised to 2. So as is strength of concrete, the C, E and A, it's the volume of cement, volume of water and volume of air respectively, and K is constant. So here if this E and A, if they are increasing, again it is decreasing your strength, and C, it is in numerator, if it is increasing, it is also increasing the strength. So he has also given this law, that is Parrott, and that is not the law, but it is the equation, simple equation given for the strength of concrete. So here volume of air is also included, because it is not only the water cement ratio but also degree of compaction, which indirectly means that volume of air filled voids, जितने ज़्यादा voids होंगे, जितना ज़्यादा air होगा, that will affect your strength of concrete. So that air voids is also equally important. That was given by Parrott. So here one relation that is given between compressive strength and water cement ratio. So just try to understand. Okay, if lower water cement ratio, it can be used when the concrete is vibrated to achieve the highest strength. We just try to understand this statement. So here this is the equation, this line you can see, it is for fully compacted concrete. So here in fully compacted concrete, just try to correlate this compressive strength versus water cement ratio. Okay, जब water cement ratio कम है आपका, तो आपकी strength higher है, and as you are going on increasing this water cement ratio, your compressive strength is decreasing. So you can say that lower water cement ratio can be used when you are having concrete which is vibrated or fully compacted concrete. And here also this vibration, that insufficient compacted concrete. So either we are using vibration or either you are using hand compaction. So here for this hand compacted concrete, comparatively higher water cement ratio can be chosen. So here you can see कि जब आपका water cement ratio कम है, so insufficiently compacted concrete when you are using, then you have to go for higher water cement ratio. So you can say that अगर water cement ratio higher है in insufficiently compacted concrete, then it will give you better strength, better compressive strength. So in both the cases, but it should not be excessive. Okay, you can say that if insufficiently compacted concrete है तो water cement ratio थोड़ा ज़्यादा होना चाहिए as compared to fully compacted concrete. Okay, but in both the cases the water cement ratio should be below practical limit. हाँ, ऐसा नहीं कि बहुत सारा कर दो, आप hand compact कर रहे हो या फिर insufficiently compacted है but दो vibrated. Both need higher water cement ratio. So one limit of water cement ratio which should be below practical limit to attain the strength. Otherwise your concrete strength will fall rapidly. तो एक strength के बाद उसका strength वापस down होना start हो जाएगा. So you have to observe that particular water cement ratio if we are doing it by insufficiently or if we are not compacting it properly, you can say, because there would be introduction of air voids and that will make your strength which is down and down. So here you can see it's a hyperbolic relation, so it's very difficult to understand. So instead of that, if you can establish certain linear relationship between this compressive strength and here the water cement ratio is not given, but it's the cement to water ratio. Okay, so water cement ratio बढ़ेगा तो strength कम होगा, but here cement to water ratio that is given. So just try this x-axis, it is cement to water ratio. So compressive strength is continuously increasing if we are increasing cement to water ratio. Okay, so this curve gives you very clear idea about what is the effect of water cement ratio or cement to water ratio on the compressive strength. So next I have told you that water cement ratio तो एक चीज है, ठीक है, but the more specific thing is that cement actually attaining strength when it is mixed with water and hydration process takes place. So the strength at any water cement ratio, it depends on the degree of hydration of cement and its chemical and physical properties. तो कितना हाइड्रेशन हो रहा है, the temperature at which hydration takes place, because hydration is basically responsible for the formation of hydrated product, and you are knowing the hydrated product. Okay, this C3S reacting with H2O. Okay, so here this it is forming this CSH gel, along with that this CaOH twice. Okay, similarly here this C2S reacting with water and giving this CSH gel. Along with that, it is forming CaOH twice. So basically, this reaction of this Bock compound C3S and C2S, which are generally forming this CSH gel. तो यही है आपका gel. Okay, that is what I'm talking about. Gel formation. Actually, it is responsible. So this hydrated particle, that is very important. जितना ज़्यादा hydration होगा, जितना ज़्यादा आपका hydrated product बनेगा, उतना अच्छा आपका strength होगा. ठीक है. So air content in case of air entrant concrete, air, how much air is there, the change in the effective water cement ratio, and the formation of the fissures and crack due to bleeding or shrinkage. Okay, so this may also take place, bleeding and shrinkage. Okay, so basically instead of relating strength to the water cement ratio directly, the strength can more correctly, you can say it's more correctly can be correlated with the solid product of hydration of cement to the space available for the formation of this product. So basically this hydrated particle is nothing but the hydrated product of CSH gel basically. Okay, and that is very important thing. So this Power and Brownier, they have established the relationship between strength and gel to space ratio. कितना space available है and कितना gel actual formation हो रहा है. So they have given that relationship between that. and this ratio is defined as the ratio of the volume of the hydrated cement paste to the sum of volume of hydrated cement and to the capillary pores. Okay, so how much space is available? जो already volume of hydrated cement है plus capillary pores. So these pores are also included in the total volume. Pores plus hydrated product, and how much hydrated product is produced per the whole space. The space include pore plus hydrated product both. Okay, so these capillary pores are to be included. So Power's experiment showed that the strength of concrete bears a specific relationship with the gel to space ratio, and this is this relationship. Okay, so strength of concrete is given in the form of 240 x raised to 3. So where x is gel to space ratio. Now here you can see it is directly proportional. Strength क्या है भाई? It directly proportional है. And 240 is the intrinsic strength जो naturally that may be available in the gel in MPa for type of cement and specification used. So this relationship between the strength and water cement ratio will hold. So you can see that this particular relationship, that is if your gel to space ratio is higher, it will give you higher strength of the concrete. So more gel is available means more hydrated product is available for the reaction, and sorry, after reaction, and that's why it is affecting positive manner in the increasing strength of the concrete. So here you have established two relationships. One is with the water cement ratio and second with the gel to space ratio. So both the relationship, how up to how much time they are holding good, so that is given. So basically this relationship between strength and water cement ratio, it will hold good primarily for 28 days strength for fully compacted concrete. So 28 days strength के लिए this relation holds good. But the relationship between strength and gel to space ratio, it is independent of age, because this gel formation, it is a continuous process. It may gain strength beyond 28 days also, but normally we are checking 28 days strength of concrete because most of the hydration that would have taken place by that time, but in it may be extending beyond 28 days. ऐसा नहीं है कि 28 days के बाद आपका strength gain बंद हो जाता है. That strength gain is going on. Okay, so this gel to space ratio can be calculated at any age and for any fraction of hydration of cement. So that can be calculated. So this gain of strength with age. Okay, so here this concrete develops strength with continued hydration, and this hydration will be continued beyond 28 days also. So the rate of gain of strength is faster in the initial time period. Okay, initially rate of gain would be faster, and the rate get reduced with the age. Means कि 28 days के बाद age आपका strength तो increase होगा, but that would not be too much. Okay, so that gain of strength beyond the 28 days, that would take place, but that will be not that much. Okay, so it is common to assume the 28 days strength as a full strength of concrete. So हम ये assume कर लेते हैं कि भाई ये, because strength is going to increase only. Okay, so 28 days strength that we are generally considering as full strength of the concrete, though actually concrete develops strength beyond 28 days also. So here in this graph you can check this. This is the strength of 50 mm cube that is given for different gel to space ratio. So you can say that if more gel is available, means more hydrated product per space is available, then it will give you continuous increase in the strength for all the mixes A, B, C. So many mixes were examined, and for all the mix of different proportion, it is observed that if gel to space ratio is increasing, means more hydrated product are available, then in that case strength is increasing. Okay, so earlier codes have not been permitting to consider this increase of strength beyond 28 days for design. कि हमको कोई जरूरत नहीं है 28 days beyond जो भी increase होता है, and that increase of strength beyond 28 days used to get emerged with the factor of safety. So factor of safety के साथ it was emerged. So here this is normally this gain of strength, though it will take place beyond 28 days. The quantity of increase, कि कितना quantity increase होता है 28 days के बाद, it depends on the grade and type of cement. कौन सा type use किया है, कौन सा grade use किया है, curing and environmental condition. and the design should be based on 28 days characteristic strength of concrete, unless there is an evidence to justify a higher strength for a particular structure due to age. So generally for design purpose, we are using 28 days strength. So these are the grades of concrete as per IS 456 2000. Okay, so this ordinary concrete that is considered, this grade is from 10, 15 and 20. So as you know that specified characteristic strength of 150 cube. So this is the specific size of the cube that if you are casting and if you are checking compressive strength after 28 days, then M20 concrete it should attain 10 Newton per mm square. Then for M15, 15, M20, 20. So these are considered to be ordinary concrete. Okay. Then for standard concrete, it is the grade from M25 to M55. So basically this 55 is nothing but it's the specific characteristics compressive strength of 150 cube. ये specify करना जरूरी है at 28 days in Newton per mm square. And high strength concrete, it is considered greater than 60 up to 80 Newton per mm square. Okay, so these are the various grades of concrete, and beyond the 28 days also they are attaining the strength because this hydration process will be continuing. So basically we are checking कि भाई 28 days का strength. Okay, so if you want to go for construction of certain structure, okay, so you are interested कि भाई पहले ही आपको पता चल जाए कि भाई strength of concrete कितना है instead of waiting for 28 days. So many times it may be necessary to estimate the strength of concrete early age. Early age पे अगर आपको पता चल गया, so it will be good for you. So one may not be able to wait for 28 days. So many research workers they have attempted कि भाई हमको पहले ही पता चल जाए तो अच्छा है ना, we can correlate it with 28 days strength. So they have tried in their research to estimate the strength of concrete at 1 day, 3 days, 7 days. So 1/4 time हो गया आपने if you are taking 7 days, and to correlate it with 28 days strength. So the relationship between the strength of concrete at lower age and 28 days. So you are checking your cube etc. at 1 day, 3 day and 7 day, and try to establish certain relationship between 28 days and lower age concrete. So they have found that it depends on many factors such as compound composition of cement. So definitely that compound composition is very important because ultimately that compound, that Bong's compound, they are responsible for formation of hydrates, and that gel to space ratio, as I have told you, that that is very important aspect in attaining the strength. So this compound composition of cement, then fineness of grinding, because if excessive fining is that more surface area would be available for the reaction and temperature of curing. So these are all the factors that are very important that are affecting the relationship between lower age strength concrete and 28 days strength of the concrete. So in Germany, the relation between this 28 days strength, that is called as sigma 28, and 7 days strength of the concrete, that is called as the sigma 7, that they have found that it lies between this. So sigma 28 is 1.4, sigma 7 plus 150, and sigma 28 is equal to 1.7, sigma 7 plus 850. So they have established that 28 days जो strength है वो इन दोनों के बीच में lie कर सकता है. Okay, and this becoming expressed in pounds per square inch. So normally they are measuring this strength in pounds per square inch. Another relationship is also established, and that is F28. So that is compressive strength after 28 days in the form of K2, F7, K1. So this F7 and F28 are the strength of concrete after 7 and 28 days respectively. And this K1 and K2 are coefficients, and which is different for the different cement and curing conditions that are to be established. Okay, so general range of this K1, it is from 0.3 to 0.8, and K2 it is from 3 to 6. So the strength of concrete जो भी है, generally we are establishing at 28 days by crushing the field test of the cubes or cylinder. As I told you, okay, we are casting cubes and cylinder which are made from the representative concrete, यूज फॉर द स्ट्रक्चर, जो स्ट्रक्चर के लिए यूज करना चाहते हैं उसी का आप रिप्रेजेंटेटिव सैंपल लेंगे, क्यूब्स एंड सिलेंडर कास्ट करेंगे, एंड आफ्टर 28 days अंडर कंप्रेशन टेस्टिंग मशीन यू विल बी चेकिंग इट्स कंप्रेसिव स्ट्रेंथ. So the utility of asserting this 28-day strength, by which time considerable amount of concrete will have been placed. अगर कोई स्ट्रक्चर के लिए आप यूज कर रहे हो एंड ऑलरेडी आपने प्लेस कर दिया है, एंड आफ्टर 28 days because already you have started your work, so it is rather too late for remedial measures. आपने टेस्टिंग को 28 दिन बाद करना है, आपने तो कंक्रीट आज ही यूज कर लिया, एंड इफ यू कम टू नो दैट सम रेमेडियल मेजर्स आर रिक्वायर्ड कि भाई ये नहीं आ रहा है स्ट्रेंथ, so it will become too late for you, because if your result of test tube after 28 days अगर आपका लो आ जाता है, आपने जिसके लिए डिजाइन किया है उतना नहीं आता है, so in that case it will be too late for you because already you have placed your concrete, so it will be difficult to go for the remedial measures. On the other hand, structure will become uneconomical if the test result of the test tube is too high. अगर आपका आपने suppose 30 के लिए you have designed and you have made it, okay, but in that case you are attaining after 28 days suppose 40, so unnecessarily you are using high strength concrete, it is not at all desirable. So in both the cases, if you are doing late, and if you are attaining higher strength or lower strength, okay, so it's better to know the strength of concrete at early age and not to wait for 28 days. That was the concept behind getting the strength result before 28 days. So it is therefore of tremendous advantage to be able to predict 28 days strength within a few hours of casting the concrete. अभी ये तो हमने 7 दिन और उसकी बात की, but you can also predict the strength of the concrete within few hours of casting of concrete also, so that we have good idea about the strength of concrete. So satisfactorily remedial measures if you want to apply, that can be immediately taken before it's too late. So it's always desirable that though our 28 days that strength that we are considering as final test, but there are many methods which are available to predict the 28 days strength and within short period of casting. So within short period of casting you will be able to predict your 28 days strength. And one of the most suggested method that is that is having good field correlation also, that is called King's method. Okay, so this King's method that is called as the King's accelerated curing test, and that is giving the test result within 7 hours. So instead of 28 days, within 7 hours you can attain the strength. So this is very simple test which is called as accelerated curing test, King's accelerated curing test. So here simple method is used. Standard cubes cast करते हैं normally, that we are casting, that is covered with the top plate and joints are sealed and special grease are to be applied to prevent the drying. Okay, so normal cube जैसे cast करते हैं, same way the cubes can be casted. Then within 30 minutes of adding water, the cubes which are properly sealed, they are placed in airtight oven. आपको airtight oven में that cubes are to be placed. Okay, so within 30 minutes you can do it. So this oven temperature is brought to 93 degree centigrade. आपको इसका temperature कर देना है 93 degree centigrade, and in about 1 hour time it may be attained. Okay, and at this temperature, so 1 hour that will be taken for attaining 93 degree, and you have to keep this cube for 5 hours. And at the end of this period, these cubes are removed from the oven. Then you have to strip it off, pull karo and test karo. So just you have to test it. So this operation is also requires around 30 minutes. So you can say earlier 30 minutes, here 30 minutes, 1 hour to bring that to that 93 degree and 5 hours in the oven. So total 7 hours. So the strength of the concrete is determined within 7 hours of casting, and this accelerated strength, it shows good relationship with the 7 days and 28 days strength of normally cured concrete. So here this relationship is shown. The strength with the normal curing, जैसे हम 28 days strength करते हैं तो normal curing, and this accelerated strength with the help of this method. So this is having good relationship. So this is 7 days strength and this is 28 days strength. So it was shown a relationship between a good relationship, जैसे ही मतलब बढ़ रहा है, so same trend is observed. So one of the main factor that affects the rate of gain of strength is fineness. So fineness is also very important property. So particles of cement over 40 micron size that are contributing to the compressive strength of concrete over long period. ज़्यादा size होगा तो long period में काम लगेगा. 25 to 30 micron cement size, they will contribute to 28 days strength normally, and 20 to 25 micron particle size or smaller than that, that will contribute to 7 days strength, and generally particles smaller than 5 to 7, it will contribute to 1 to 2 days strength. So here you can say this fineness of grinding. So normally the fineness, higher fineness, that will give you more surface area to react, and that will work very fast, and that will contribute to the early strength of concrete. And जैसे जैसे size बढ़ता है, that will be responsible for later strength of concrete. Okay, so generally this relative gain of strength with the time of concrete made with the different water cement ratio using OPC, you can see that there is a perfect relationship that is established. You can see this 1 day strength, 3 days strength. This is 1 day, 3 days, 7 days, and 28 days. So there is a good relationship that was observed for all cement water cement ratio. So you can say that by doing such test, you can establish a good relationship. So instead of waiting for 28 days, you can, if you are having a certain concrete, and you can establish a good relationship between this 1 day, 3 day, and 7 day strength. So very early you can predict the 28 days strength. Okay, and that was this King's accelerated curing test that is giving such kind of good relationship, and that can be obtained. So in this particular strength aspect today, we have discussed the major factors which are affecting strength of concrete. Okay, so in the next class I will focus more on other different aspect related to factors which are affecting strength of concrete. Thank you very much.